The idea of building a jet fighter in Germany took shape at almost exactly the same time German engineers started developing the turbojet engine itself. Back in the 1930s, designing this kind of power plant was considered the absolute toughest, most research-intensive part of building the whole aircraft. The airframe, on the other hand, was basically treated as an afterthought. They initially designed it using old aerodynamic rules. They acted as if air didn't compress at high speeds and completely ignored these new aerodynamic effects. The wind tunnels of the time simply couldn't give them a full picture of how the aircraft would behave. They didn't even know if it would be controllable once it approached the speed of sound and pushed past Mach 0.6. Because of this, the airframe was actually finished before the engine. But once they began those early test flights, it became blatantly obvious that it just wasn't built to handle such extreme speeds. Ultimately, the designers had to admit that developing a proper airframe was going to take just as much time and effort as the jet engine itself. Work on this new fighter, which went by the working title P-1065, kicked off in October 1938. The original plan called for a pair of P-3302 jet engines, each putting out around 1,320 pounds of thrust. Engineers hoped this twin-engine setup would push the fighter to 560 miles per hour. But the aircraft's final design didn't come together overnight. Its development was a lot like natural evolution. It shifted from incredibly basic shapes to highly complex engineering solutions. Working around the dimensions of the BMW engines, chief designer Willy Messerschmitt signed off on the first version of what would eventually become the Me-262. This early prototype featured a conventional straight wing and a tail-dragger landing gear setup. Interestingly, they initially decided to mount the engines flush against the sides of the fuselage. The designers clearly wanted to reduce aerodynamic drag. They also wanted to keep the aircraft more controllable in the event of an engine failure. This was a huge deal since the reliability of early jet technology definitely left a lot to be desired. But out on the flight line, this layout made servicing the aircraft a massive headache. On top of that, the engine exhaust severely disrupted the airflow around the tail and fuselage. This led to a serious drop in overall thrust. This configuration didn't last long. Further testing showed that those early engines simply didn't have the thrust to hit their target speeds. The project desperately needed significantly more powerful engines. This meant dealing with completely different physical dimensions. To make matters worse, it became obvious that BMW was running into major technical roadblocks. They just weren't going to have their engines ready in time. This triggered the first major departure from the original blueprints. The engineering team essentially had to design a brand new aircraft. This time, they slung the engines in pods under the wings. In its final form, the aircraft's fuselage ended up with a highly distinctive triangular cross-section. It was noticeably wider at the bottom than it was tall. Most aviation historians agree they went with this specific shape for a very practical reason. They needed to pack in 4 fuel tanks holding around 680 gallons. At the same time, they had to leave enough room for the main landing gear to retract inward. Plus, when paired with the low wing design, this fuselage shape did a fantastic job of solving that earlier aerodynamic interference issue. To really grasp just how brilliant this design choice was, you only need to look at the numbers. The aerodynamic drag of the Me-262 fuselage was noticeably lower than that of iconic aircraft like the Bf-109 or the HE-177. And that held true at absolutely any airspeed. Figuring out the armament was another long, drawn-out process. At first, they looked at a setup with 3 MG-151 machine guns. Then they tossed around the idea of packing the fuselage with 2 20mm MG-151 cannons, alongside a much more devastating 30mm Mk-103 cannon. They also considered sticking 2 more machine guns directly in the wings. However, even this massive arsenal would not be the final configuration. Basically, the design of this jet was geared toward mass production right from the start. The engineers aimed for a highly modular construction. This meant different sections of the fighter could be manufactured at dispersed factories. They could then be easily brought together for final assembly. However, the war had other plans. Because of a severe aluminum shortage across Germany, the designers had to make some major compromises. To keep production moving, they started heavily using steel and even wood in the airframe construction. This naturally made the aircraft significantly heavier. The design review for this ambitious project took place in January 1940. Just 2 months later, the engineers were awarded an official contract. They were to build the first 3 experimental prototypes for extensive flight and structural integrity testing. But, as is so often the case in aviation, plans had to change fast. The main issue was a serious delay in developing the new engines. Plus, right around this time, a much more promising alternative appeared on the horizon. This was the Jumo 004 turbojet from Junkers. Initial testing had already started back in the fall of 1940. But this powerful new power plant was still very rough around the edges, and it needed a long, painstaking period of refinement. Since flight-ready turbojets were still nowhere to be found, the initial plan was to temporarily fit the first prototype of the legendary Me-262 with 2 liquid-fueled rocket engines. Each one was supposed to produce about 3,300 pounds of thrust, but they also needed a lot of work. Time was working against the designers, so they made a compromise. They mounted a conventional liquid-cooled V12 Jumo 210G piston engine producing 750 horsepower. It was in this somewhat unusual setup that the first Me-262 finally took to the skies on April 18, 1941. At the controls of this historic aircraft was the renowned German test pilot Fritz Wendel. At that point, the takeoff weight of the aircraft was just over 5,860 pounds. Its top speed in level flight was pretty modest, barely hitting 258 miles per hour. Testing on this prototype dragged on until the end of July 1941. Over that time, the team of engineers and pilots managed to thoroughly study the maneuverability of the aircraft. They got a solid feel for its handling characteristics and evaluated the flight control forces. This helped them spot structural weak points, and it allowed them to successfully iron out the early teething problems. Things started to change in mid-November 1941. This was when the first flight-ready BMWP-3302 turbojets finally arrived at the plant in Augsburg. However, their thrust was frankly underwhelming, peaking at no more than 1,014 pounds each. Because of this, the designers came up with a practical workaround. They mounted the new jet engines onto the experimental Me-262, but they decided to play it safe and leave the reliable Jumo 210G piston engine right there in the nose. The first flight of this bizarre 3-engine hybrid took place on March 25, 1942. Fritz Wendel was at the controls once again, and that day almost turned out to be his last. Getting the jet-powered Me-262 off the ground at the Hounstetten airfield proved to be incredibly difficult. Even with all 3 engines running, the heavy aircraft only managed to lift off at the absolute end of the runway. The airplane climbed slowly and unsteadily to an altitude of about 150 feet. But the second the pilot tried to retract the landing gear, disaster struck. The left jet engine suddenly failed, and a few seconds later, the right one died as well. The only thing that saved the pilot's life and the airplane itself was that old Jumo 210G piston engine. Thanks to it, Wendel was able to skillfully bring the faltering aircraft around. He pulled off an incredible emergency landing back at the airfield. This near-fatal incident was a glaring reminder of just how unreliable the world's first turbojet technology really was. While engineers were scrambling to tweak the problematic BMW engines, tests on another power plant were successfully wrapping up on a flying testbed. This was the Jumo 004. This new engine put out a much more respectable 1,850 pounds of thrust. But it was not just more powerful, it was also significantly heavier and bulkier. Because of this, designers had to create entirely new engine mounts and streamlined nacelles. A pair of these powerful engines was installed on the next Me-262 prototype. This version of the aircraft still featured a conventional tailwheel landing gear, but it finally ditched the dead weight of the piston engine. On the morning of July 18, 1942, lead test pilot Fritz Wendel was getting ready to take the updated aircraft up from an airfield near the town of Günzburg. But during the takeoff roll, the unexpected happened. Despite all the mathematical calculations, with just under 1,000 feet of runway left, the pilot realized a major problem. He simply lacked the elevator authority to get the tail off the ground. A terrible crash was avoided only thanks to Wendel's split-second reaction to slam on the brakes. It also helped that the local runway was much longer, stretching nearly 4,000 feet. As it turned out later, the cause of this failure was aerodynamic blanking. The airflow was separating from the wing, completely blanking out the fighter's tail section. Getting the stubborn jet off the ground only worked on the second try. Doing so required a highly unconventional piloting trick. When the aircraft reached takeoff speed, Wendell lightly tapped the brakes for a split second. This created a sudden pitch-down moment, popping the tail up and allowing it to lift off the runway. Once in the air, the pilot immediately noted something important. Despite all the difficulties on takeoff, handling the updated airplane was much smoother and easier than its previous prototypes. That very same day, the tireless pilot made another flight. This finally confirmed the engineer's suspicions that the airflow was separating from the center section of the wing way too early. This early separation was compromising the aircraft's stability. To fix this problem and improve the fighter's aerodynamics, the designers made some major changes. They slightly thickened the airfoil, widened the wing root, and increased the leading edge sweep. This gave the airplane an even more predatory silhouette. As for the heart of the fighter, at maximum power, the jet turbines spooled up to a screaming 8,700 RPM. The engine itself was an absolute giant for its time. It was nearly 13 feet long and weighed in at just over 1,500 pounds dry. However, the technology of the day demanded a steep price for all that power. The operational lifespan of this innovative engine was a mere 25 hours. After that, it had to be completely replaced. Flight testing of the third prototype was short-lived. On April 18, 1943, the aircraft crashed with test pilot Wilhelm Ostertag at the controls. Initially, investigators blamed the crash on a failure of the electric pitch trim system. However, a closer look at this and similar accidents revealed much deeper flaws. These flaws affected both the jet engines and the airframe. The main culprit was a highly unreliable fuel control unit. If it failed, the aircraft would experience sudden asymmetric thrust. This caused it to yaw violently and enter an uncontrollable roll. On top of that, aerodynamic blanking reduced the effectiveness of the tail surfaces. This severely compromised the longitudinal stability of the aircraft. It made it incredibly difficult for the pilot to control pitch. That same April, the fourth Me-262 prototype joined the flight test program. This was the exact aircraft in which legendary German ace and inspector of fighters Adolf Galland made his first jet-powered flight. Galland was highly impressed. He praised the handling of the new fighter. He particularly noted its outstanding maneuverability. His enthusiastic endorsement played a pivotal role in accelerating the entire Me-262 development program. Following his flight, Galland recommended several major design changes. He insisted on increasing the internal fuel capacity to extend the range of the aircraft. He also pushed for transitioning to a tricycle landing gear configuration. Specifically, he wanted a nose gear installed. This way, the aircraft would sit level on the tarmac instead of in a conventional tail-down attitude. This fourth prototype was the last to feature the older tailwheel configuration. Moving forward, all the new systems intended for production Me-262s were first evaluated on dedicated flying testbeds. For example, the Me-309 was used to test and refine the pressurized cockpit and ejection seat. Meanwhile, the new nose gear was tested for reliability on a specially modified Bf-109. Regarding emergency egress systems, an important historical milestone occurred in 1944. Germany issued an official directive requiring all new combat aircraft to be equipped with ejection seats. This included the groundbreaking Me-262. The goal was to increase pilot survivability. While it might seem like a straightforward device, the early ejection seat was actually an incredibly complex engineering challenge. To determine the maximum G loads the human body could withstand during the violent acceleration of an ejection sequence, engineers required live testing. Today, such parameters are simulated on computers. They are then verified with test dummies and only after that tested by human volunteers. German engineers in World War II, however, lacked both modern technology and the time for safe, methodical research. This led to a horrific humanitarian tragedy. The brutal live tests for these early ejection seats were conducted on prisoners from Nazi concentration camps. Despite its dark and unethical origins, the technology did work. By the end of World War II, around 60 Luftwaffe pilots had successfully used ejection seats to escape from crippled aircraft. Meanwhile, development of the fighter continued at a rapid pace. The early prototypes were followed by the next iteration of the Me-262. This airframe finally featured the tricycle landing gear. However, the nose gear was initially fixed and did not retract in flight. This updated aircraft took to the skies for the first time on June 6, 1943. It served as the direct predecessor to the first full production model, the Me-262A series. Much later, in 1953, Adolf Hitler published his memoirs. In the book, the legendary ace described his experience, writing that the jet-powered Me-262, the fastest fighter in the world, had finally become a reality. He recalled how he had just flown it, and knew for a fact that this aircraft was head and shoulders above anything else in the sky. He admitted it still had some technical issues and teething problems. But according to Galland, everyone who gathered at those meetings in the spring and summer of 1943 understood one thing perfectly. They had to do everything possible, right away, to seize this last chance. To make that happen, they had to take massive risks and find unconventional solutions. That was when they made a unanimous decision to immediately start building an initial batch of 100 airframes for both advanced flight testing and frontline combat trials. Hermann Göring was equally swept up in the enthusiasm. As Galland noted, Göring wouldn't have been a true fighter pilot if he hadn't understood that excitement right after the first test flight in the Me-262. Right there in front of him, Göring got Field Marshal Erhard Milch on the phone. At the time, Milch actually had the detailed report sitting on his desk, outlining their proposals for the aircraft's future. Milch was completely on board. All the ideas and proposals were accepted with incredible speed and a genuine eagerness to act. At moment, Galland honestly thought he had won a complete victory on all fronts. Given the unanimous agreement among the top aviation experts, there was little doubt that the Reichsmarschall would be able to secure Adolf Hitler's approval, which was absolutely vital for making such a critical strategic decision. The next morning, Hermann Göring headed to headquarters to personally brief Hitler on all the technical details. But to everyone's utter shock, the Führer refused to give his approval. The reality was, even back then, Hitler treated Göring, and really the entire Luftwaffe, with deep distrust. He wanted to see for himself whether their proposals would actually work. He tore into Göring, and to be fair, not without good reason. He argued that the Luftwaffe had disappointed him way too often with overhyped new aircraft and endless modifications. For instance, the HE-177 heavy bomber had been promised to the front lines by 1941 at the latest. Yet it was still completely unclear when the bomber would actually be ready for frontline service. Because of this, Hitler declared there was no need to rush the brand new Me-262 either. He strictly forbade taking any further action until he made his own final decision. As a result, series production of the Me-262 was now delayed by at least another 6 months. This production had already been stalled for almost a full year back in 1940 by Hitler's direct order to pause development. Because of these constant setbacks in the Me-262 program, a year and a half of precious time was lost forever. As Galland later recalled, by late 1943, the Me-262 suddenly caught the attention of the top brass once again. This happened under conditions that had deteriorated even further over the previous 6 months. Its production was finally added to the priority armaments program and treated as a matter of extreme urgency. On November 2, 1943, Hermann Göring personally visited Willy Messerschmitt's production facilities. He wanted to see exactly where things stood for himself. During a conversation with Professor Messerschmitt, a topic came up that would later prove fatal. It would play a decisive role in the ultimate tragedy of this unique jet fighter. Göring flat out asked Messerschmitt if the Me-262 was capable of carrying 1 or 2 bombs. He added that the Führer had spoken to him about this a few days prior and placed a great deal of importance on the idea. Galland had no idea about these crazy plans to use the Me-262 outside its intended role as a fighter and convert it into a bomber. He only found out about it later in December 1943 when he attended a major demonstration of new aircraft at the Insterburg Air Base in East Prussia. Adolf Hitler himself arrived from his headquarters located just nearby. He took a genuine special interest in the Me-262 jet. Galland was standing just a step away from Hitler when the Führer suddenly turned to Göring and asked if this aircraft could carry bombs. Hermann Göring hastily replied that yes, in theory, it definitely could. He stated its payload would be at least 500 kilograms and possibly even a full 1,000 kilograms. In reality, though, the design of the Me-262 at the time did not have any hardpoints for carrying bombs. It had no bomb release mechanisms. And it certainly had no bomb sight. Objectively speaking, this aircraft simply was not suited for precision bombing. This was due to its flight characteristics and the limited visibility from the cockpit. But Hitler continued, stating that for years he had been demanding the Air Force build a high-speed bomber that could reliably reach its target without having to worry about enemy fighters. He saw a lightning-fast bomber in this aircraft, yet it was being presented purely as a fighter. Hitler argued it would be capable of repelling an enemy invasion right in its early, weakest stages, and complained that none of them had even thought of that. And on that point, Hitler was actually right. None of the Luftwaffe experts had really considered that scenario. And frankly, even then, they still thought the idea was fundamentally flawed. So the original program for the production and detailed testing of the Me-262 as a dedicated fighter went ahead without any changes. Gallon formed a special test unit with the backing of the main test center and the Messerschmitt plant, including their most experienced test pilots. They soon began flying actual combat missions against Allied daylight Mosquito reconnaissance planes. Finally, they had a fighter in their hands that could outrun the fastest Allied aircraft, and very quickly that advantage proved itself as the first convincing combat victories were scored. In February 1944, Allied air forces carried out a massive operation codenamed Big Week. These were devastating raids on key targets in the German aircraft industry. They dealt a severe blow to the production of the new Me-262 jet fighter. The Augsburg and Regensburg plants were bombed. Because of this, 100 aircraft never rolled off the assembly line. Their construction was already far behind schedule. A severe shortage of skilled labor and essential materials caused further delays. This pushed the start of full-scale production all the way back to late March 1944. 4 weeks later, the first production aircraft finally reached the final assembly hangars in Leifheim. But they met a tragic fate. On April 24th, those planes were completely destroyed during a heavy daylight raid by American bombers. Finally, in October 1944, there was a breakthrough. The Luftwaffe High Command received a direct order from Göring. They were told to take the two test units at Lechfeld and Rechlin and form them into an operational jet fighter wing. This unit was meant to operate on the Western Front. Through its actual combat successes, it would convince Hitler that the Me-262 was absolutely unmatched as a fighter. Once the green light was given to stand up the first Me-262 fighter unit, the incredibly tough assignment was handed to Walter Nowotny. The unit was formed at a base in the town of Achmer near Osnabrück. At the time, Nowotny already had 250 kills under his belt. He was rightfully considered the top scoring fighter ace in Germany. He tackled the assignment with incredible enthusiasm and boundless energy. Eventually, Nowotny's group became the foundation around which another legendary pilot, Johannes Steinhoff, formed the first jet fighter wing in history. It was designated Fighter Wing 7, or JG-7. The leadership of the Third Reich was busy having long, heated debates over what exactly to do with this groundbreaking aircraft. Meanwhile, engineers went ahead and built the seventh test prototype. This was the Me-262 V7. Unlike its predecessors, this prototype featured a fully pressurized cockpit. To give you an idea, when the aircraft climbed to roughly 39,000 feet, the cabin pressure was maintained at a comfortable level. This was equivalent to an altitude of about 20,000 feet. Engineers also installed a new canopy. It offered much better visibility by reducing the amount of metal framing. Flight testing for this prototype kicked off on December 20th, 1943. Shortly after, the next prototype took to the skies. It was the Me-262 V8. This was the first airframe to be fitted with its full standard weapons payload. It packed a massive punch with four 30mm Mk-108 cannons. These carried a total of 360 rounds, paired with a Revi 16B gun sight. Next came the Me-262 V9. It was built specifically for detailed testing of the radio and navigation equipment. This exact airframe later served as the second prototype for the full production Me-262A series fighter. A bit later, in early 1944, the German aviation industry rolled out a new batch. This consisted of 30 pre-production Me-262A0 fighters intended strictly for operational testing. Half of these jets were handed over to a test unit at the Lechfeld airfield. It was commanded by Captain Werner Thierfelder. There, pilots were not just learning how to fly the new aircraft. They were essentially writing the book on jet fighter tactics. The other half of the pre-production jets were sent to the test center at Rechlin. During these flight tests, one of the most complex problems of early jet aviation emerged. It was an issue engineers would not solve for quite some time. The aircraft would experience severe Mach tuck. It would suddenly and uncontrollably pitch down into a dive once it pushed past Mach 0.8. Soviet test pilot Andrei Kokotkov later miraculously managed to recover a captured Messerschmitt from this kind of deadly dive. However, this did not mean engineers actually understood what was causing it. The phenomenon was not fully explained until 1947. This was highlighted by the publication of an article by German test pilot Ludwig Hoffmann. He wrote a paper on high-speed flight in the Me-262, which was published in the Soviet Union. The foreword made a blunt statement. Because many aerodynamic phenomena at high Mach numbers still lacked a satisfactory explanation, it would be highly beneficial for Soviet engineers to familiarize themselves with his data. This was a pretty interesting and honestly somewhat strange way to frame it. After all, by that time, the experimental LA-160, featuring a swept wing, was already flying successfully in the Soviet Union. On top of that, the Central Aero Hydrodynamic Institute had already wrapped up large-scale wind tunnel testing. This testing was done on models of the brand-new MiG-15 and LA-15 fighters. This meant that by then, the big mystery behind aircraft uncontrollably tucking into a dive at transonic speeds had actually been completely solved. These mysterious and tragic crashes usually played out following the exact same scenario. When the jet-powered Me-262 reached high speeds during straight and level flight, it would suddenly and violently pitch down. It would go into a steep dive without any pilot input. At that point, there was simply no way for the pilot to pull the heavy aircraft out of the fatal dive. Conducting a proper investigation and pinpointing the exact cause of these incidents was virtually impossible. The pilots were killed on impact. The aircraft themselves were reduced to mangled metal after hitting the ground. This aerodynamic flaw ended up killing Messerschmitt's chief test pilot, along with several experienced Luftwaffe pilots. The strangest thing all these crashes had in common was that none of the pilots radioed a distress signal or sent any kind of message. This happened even though they had plenty of time to do so. Furthermore, right up until the moment of impact, observers on the ground didn't see a single sign of structural failure or fire on board. The aircraft just dropped like a rock. The road to mass production wasn't easy. After a series of flight tests, engineers finalized a prototype to serve as the baseline. Using this as a foundation, engineers ironed out the teething issues discovered during testing. The Germans then rolled out a pre-production batch of 30 airframes. It was only after these aircraft went through rigorous evaluation that the world saw the first full production variant. This was the Me-262A1A. This specific model became the foundation for all later versions of the legendary jet fighter. The military gave the Me-262A1A the nickname Schwalbe, which translates to swallow. In July 1944, the aircraft joined a special test squadron. At its core, the production Schwalbe was practically identical in design to the experimental pre-production batch. To ensure flight safety, High Command issued strict flight envelope limits. When flying at speeds up to roughly 500 miles per hour, pilots were instructed to trim the aircraft for hands-off flight. As airspeed increased, they had to adjust the horizontal stabilizer to maintain a slight nose-up pitch. Exceeding 560 miles per hour was strictly forbidden. It is worth noting, however, that during factory testing, a few daring test pilots managed to push the airframe. They reached an incredible 610 miles per hour. At an altitude of nearly 23,000 feet, that translated to Mach 0.875. This was pushing dangerously close to the sound barrier. But the design definitely had its strong points. For example, the Me-262A1A could maintain stable flight even if it lost an engine. In a single-engine emergency scenario, it could still cruise comfortably. Speeds would sit at around 280 to 310 miles per hour. Flight time at roughly 23,000 feet could stretch out for over 2 hours. You have to admit, though, that attempting a single-engine landing was highly unforgiving. Or worse, trying to continue a takeoff after an engine failure was considered extremely dangerous. The jet's firepower was devastating. Its main armament consisted of 4 massive 30mm Mk-108 cannons. The top 2 cannons had 100 rounds each, while the bottom 2 carried 80. Opting for such heavy armament made the aircraft's primary mission crystal clear. That mission was the ruthless destruction of heavy bombers. Engaging in a turning dogfight with agile, lighter fighters wasn't even on the table. If the designers had intended to build a dedicated dogfighter, they would have stuck with the smaller caliber weapons. These weapons had already proven highly effective on piston engine fighters like the Bf-109 and Fw-190. But in practice, a major problem emerged. The fire from these cannons was only truly effective at short ranges, under 250 yards. Meanwhile, the gunners on those American heavy bombers could easily engage German fighters. They used their .50 caliber machine guns from over 750 yards away. Because of this massive gap in effective range, the Germans took heavy losses during their attack runs. Since these jets were so easily shot down by standard defensive fire, the conclusion was obvious. The armor protecting the cockpit and vital systems of this cutting-edge fighter was simply too weak. To turn the tide, engineers proposed a new variant specifically designed for hunting bombers. This was the Me-262D. They planned to turn this aircraft into a true aerial monster by packing 12 50mm SG-500 Jagdfaust cannons right into the nose. These were meant to fire at an upward angle. They would shoot straight into the vulnerable belly of an enemy bomber as the fighter flew underneath it. To make sure the heavy recoil from the volley would not tear the aircraft apart, designers came up with a clever solution. Upon firing, the heavy shell casing would be ejected downward, completely canceling out the recoil energy. But the real breakthrough, and an even more effective weapon, was the 55mm R4M unguided air-to-air rocket. These were equipped with a solid propellant rocket motor and stabilizing fins that deployed immediately after launch. Each rocket was 32 inches long, weighed 8.5 pounds, and carried a warhead weighing just over a pound. In the air, the R4M accelerated to around 330 miles per hour. Its effective range reached roughly 1,500 to 2,000 yards. This allowed pilots to fire from well outside the bomber's defensive perimeter. A special optical sight was used for precise targeting. Under the wings of the new Me-262A1B variant, up to 24 of these rockets could be mounted on basic wooden launch racks. This made the aircraft the perfect weapon for breaking up bomber formations. To understand just how devastating this arsenal was, you just have to look at the combat records. According to the well-known military historian K.J. Becker, in the last week of February 1945 alone, elite pilots equipped with these new rockets managed to shoot down 45 four-engine heavy bombers. This was along with 15 of the escort fighters trying to protect them. A significant portion of the Me-262s that rolled off the assembly line never even made it into the sky. Many of these innovative jets were destroyed during factory testing. Others were caught right on the tarmac when airfields were blanketed by massive Allied bombing raids. Historians often point out that only about a quarter of all the airframes produced actually saw combat. The Me-262s that survived long enough to reach the front were assigned to special aviation units. At first, they were pooled into an experimental test unit known as Commando 262. Later on, these high-speed jets reinforced elite fighter wings, night fighter squadrons, reconnaissance units, and even bomber wings. In these units, bomber pilots had to quickly retrain and step into the unfamiliar role of flying fighters. The combat debut for the jet took place on July 25, 1944, when a German pilot successfully intercepted an RAF Mosquito. But it was not until September 11th that the new jets first clashed with American heavy bombers. They attacked a formation of B-17s heading back from a massive raid over Germany under heavy escort from P-51 Mustangs. In that first major engagement, the Germans only managed to shoot down a single P-51. However, by the very next day, their effectiveness noticeably spiked. Captain Georg Peter Ader managed to single-handedly shoot down at least 2 of the massive flying fortresses. Following the tragic death of its previous commander Thierfelder, Kommando 262 was expanded into a full-fledged fighter group. It was taken over by one of the most famous German aces, Major Walter Nowotny. At the beginning of October, this elite unit was relocated to new airfields near the city of Osnabrück. It fielded anywhere from 30 to 50 jets. This location was not chosen by chance. It sat directly under the main bomber streams flown by British and American armadas. By October 3, 1944, the fighter group was fully operational. But any initial success was short-lived. Just 4 days later, the Germans lost their first 2 jets, shot down by fast and agile American P-51 Mustangs. Major Nowotny wouldn't command this unique unit for long. On November 8th, his aircraft was shot down in a fierce dogfight. The exact circumstances of his death remain a mystery to this day. According to some historical accounts, after Nowotny successfully shot down 3 B-17s, he radioed frantically that his left engine had suddenly flamed out. He also reported that he was under attack by a swarm of American Mustangs. For unknown reasons, the pilot never bailed out. His out-of-control jet dived into the ground about 3.5 miles north of the small town of Bramsche. Despite the losses, German pilots kept fighting with incredible intensity. Between October 3rd and October 12th, the pilots of this unit flew 3 or 4 sorties every single day. According to their own reports, in this short time, they claimed between 22 and 26 Allied aircraft, proving the deadly potential of the new jets. In the early stages, deploying the Me-262 against American and British aircraft was stunningly successful. The Germans' main weapon was absolute surprise. The top speed of these jets exceeded the best Allied piston engine fighters by at least 125 miles per hour. Their hit-and-run tactics relied on speed and shock. The jet fighters would attack in small flights of 2 to 3 aircraft. They would dive out of the sun, holding an altitude advantage of about 1,500 to 3,000 feet. After shooting down a few heavy bombers and sowing chaos in their tight defensive formations, the Germans would vanish into the sky at blistering speeds. Closing at such high velocities, they rarely had time to come around for a second pass, but it was still enough to get results. However, this tactical advantage didn't last long. The aerial gunners on the American bombers quickly recovered from their initial shock and fear of these unknown propellerless aircraft. The Allies adapted, laying down massive walls of defensive fire from dozens of heavy machine guns at once. On top of that, Allied fighter pilots came up with a clever counter-tactic. They would brake hard and intentionally bleed off their airspeed. For the high-speed Me-262s, this was fatal. Their early jet engines and swept-wing aerodynamics simply wouldn't let them fly that slowly without stalling. The German pilots would instantly lose the initiative in a low-speed turn fight. As a result of these new Allied tactics, losses among the German pilots began to climb rapidly. It got to the point where the once fearsome Kommando 262 had only 3 operational Me-262s left. Eventually, by order of General Adolf Hitler, the remnants of the unit were reorganized. In honor of their fallen commander, they were renamed Kommando Nowotny and folded into a newly formed fighter wing. The new home for these jets was a secret airfield built right on the edge of a forest. Facing total Allied air supremacy, the Germans had to operate very carefully. All aircraft were dispersed and heavily camouflaged among the trees. They were rolled out onto the runway only at the very last moment right before a sortie. For the most part, the pilots took off in pairs so they could provide mutual support immediately after liftoff. The aerial victories scored by the pilots of the German JG-7 fighter wing were truly impressive. This is especially true when you consider the sheer scale of these engagements. These were massive air battles where hundreds of warplanes from both sides would clash in the skies. For instance, on March 17th, several brand-new Me-262 jet fighters scrambled to intercept American B-17 bombers. These bombers were carrying out devastating raids on the cities of Ruhland, Bohlen, and Cottbus. In that fierce engagement, Unteroffizier Koster shot down 2 flying fortresses. Meanwhile, Oberleutnant Wegmann and Oberfeldwebel Goebel each destroyed another enemy bomber. The following day, an even larger battle unfolded. Over 1,200 heavy bombers, escorted by 632 fighters, set a course straight for Berlin. To intercept them, the German command launched a massive air defense force. This included about 40 Me-262 jets from JG-7. Punching through the tight escort screen of P-51 Mustangs, the Messerschmitt jet pilots claimed the destruction of 12 bombers and 1 enemy fighter. But that attack did not come cheap. In the battle, the Germans lost 6 of their advanced jets and 2 pilots. Of course, getting to the truth about actual kills and losses requires a careful look at archival records from both sides. Wartime press and post-war memoirs often throw out some pretty contradictory numbers. For example, after tallying up their losses from the raid, the Americans officially reported 24 bombers and 5 fighters failing to return to base. The fighting did not let up for a single day. On March 19th, 45 Me-262s, some packing extra firepower in the form of air-to-air rockets, intercepted another massive B-17 formation near Chemnitz. 6 American heavy bombers fell victim to this rocket barrage, but once again the Germans did not walk away unscathed. The fast American Mustangs managed to shoot down 2 of the jet fighters. Allied air raids on Germany were happening daily. By the end of March, Me-262 pilots claimed 118 aerial victories against 34 combat losses of their own. On paper, their kill-to-loss ratio was better than 3-1, but you have to take those statistics with a heavy grain of salt. As is often the case in war, adrenaline-fueled pilots returning from a dogfight frequently overclaim their actual kills. Against the backdrop of these events, in early February 1945, the German High Command decided to form a brand new elite fighter unit. It was designated JV-44, or Jagdverband 44, which literally translates to hunting unit. The legendary German ace Adolf Hitler took command of the group. At first, the unit had 25 jets on strength. However, due to constant technical issues and resource shortages, they were down to just 16 Me-262s and 15 combat-ready pilots by the time active operations began. Once formed, JV-44 deployed to the Lager Lechfeld and Munich-Riem air bases. That spring, they started flying interception sorties against the American bombers from those bases. The pilots of this elite unit scored their first kills on April 5th, when 5 Me-262s managed to take down 2 enemy bombers. But there just were not enough of these successful sorties to make a dent in the overall air war. The sheer desperation of the German pilots is captured perfectly in their personal diaries. On September 10, 1944, Luftwaffe pilot Heinz Knoke wrote this entry: "The German Air Force is slowly bleeding to death trying to defend our airspace. Our cities and vital factories are completely in ruins, standing practically defenseless against the methodical and ruthless bombing runs by the British and the Americans. And yet, at this exact same time, the only thing Hitler can think about is some mythical thirst for revenge." Knoke went on to write that if they were just given 1 or 2 fighter wings fully equipped with the brand new Me-262s, they would have a solid chance of turning this disastrous situation around. Looking back today, we can clearly see just how naive this desperate faith in a wonder weapon truly was. Ultimately, the Me-262 earned its place in history as the combat pioneer of the jet age. But in reality, the aircraft was rushed into service and still plagued by teething issues. Its heavy cannon armament was prone to jamming, and the pilots severely lacked the time needed for proper training. That is exactly why this incredible technological breakthrough was never able to make a significant impact on the course of World War II. And let us be honest, under those conditions, it simply never stood a chance.